Okay guys, this is a continuation of solving polynomial equations using the fundamental theorem of algebra. And I figured another couple of examples to work through might be extremely helpful. So here we go. What I'm trying to do for each of these guys is I'm going to try to solve, right? I'm going to try to find all solutions. And as I look at this one, my degree is 5, so I know I'm looking for 5 solutions. Now once again, it's set equal to 0, that's great. It's in standard form, that's also great. I'm going to look to factor if I can, that's going to make my life easier. Unfortunately, there is no GCF, and there's 5 terms, and I don't know how to factor that. So we're going to have to turn to our handy calculator. So again, everything I just wrote is going to kind of disappear for a second. I'm going to bring up my calculator, and I'm going to enter in y equals my equation. It's x to the 5th minus 2x to the 4th plus 8x squareds minus 13x plus a 6. Let me double check that's right. X to the 5th minus 2x to the 4th plus 8x squared minus 13x plus 6. Yep, looks good. I'm going to hit the graph button, and I see this. Now again, let me kind of speak to a couple of things. Keep in mind, this looks strange. It looks like a line here, right? And then like a parabola over there. But it's really not, guys. That's not a line and a parabola. This is a 5th degree polynomial with a leading coefficient of 1. And if you remember end behavior, that means it goes up here and down here. And what we're catching right now is really what's going on in here, where it's going up and then it's like coming back down here and doing like, oops, maybe not quite as accurate as I wanted it to be, or I would need a little bit more accurate. So it is connected. We just don't really care what's going on up here and down here. All we care about, remember, is what's happening around the x-axis. And as I look at this, I hope you're kind of getting the hang of this. This looks like a cut to me, which means there's only one solution there, and it looks like it's at -2. We're going to verify in a second. And this guy looks like not a kiss and go, but just a kiss, which means an even number of repeats. And it looks like that's happening at x equals 1, and we're going to kind of double check that in a second. Okay, I'm going to erase this, and I'm going to use my calculator's trace feature to verify. So if I hit trace, oops, I got to exit out here. So I'm going to hit trace. First, got to turn it back on. Trace, and I'm going to type in -2 because that's where I think it hits 0, and yes, it does. I see when I have x is -2, I get y is 0. So that's one solution. And if I try, let's see, 1 for x, and I hit enter, I also get a 0, which is great. That means I have an even number of repeats there. Now, this is what's a little exciting about this one, at least in my geeky mathematical mind. I know I have just, where's my pen? I know I have definitely one solution at, what was it, -2. That's one solution. Now, there's an even number of repeats at x is 1. Now, that means it could be a 1 and a 1, right? That's an even number. Or it could mean that it's a 1, 1, 1, and a 1. Now keep in mind, it is possible that there could be 4 ones, that's even, right? 4 is an even number, and 1 -2 for a total of my, remember there was 5 solutions. Now you might be thinking, oh, that's sweet. Let's just kind of roll with this and let's call it a day. There's our 5 solutions. Let's move on. Well, we don't know. It could be that there's just these 2 and then maybe 2 more that are imaginary, right? So the only way to verify, guys, is to synthetic divide out, and I would start by synthetic dividing out that -2, then we'll synthetic divide out as many ones as we can, and if we synthetic divide out 4 ones and get zeros, then we know we're good. Okay, but if on this like third 0, if we try and we don't get a 0, it's not going to work. So this is what I suggest we do. Let me erase a little bit of my shenanigans. I'm going to first play it safe and just let's assume it's definitely just two ones. So the coefficients that I'm going to synthetic divide with, first I'm going to synthetic divide out a negative 2. There's 1x to the fifth. There's negative 2x to the fourths. Now there is no x cubed, so I'm going to put 0 for x cubed. And then there's 8x squareds. There's negative 13x's. And there are 6 just as a constant. So if I synthetic divide, I drop the 1, I multiply, I get negative 2. If I add, I get negative 4. If I multiply, I get 8. If I add, I get 8. If I multiply, I get negative 16. When I add, I get negative 8. If I multiply that, I get positive 16. When I add, I get negative 3. If I multiply negative times negative, I get positive 6. Uh-oh. I think I made a mistake here. Negative 13 plus 16 is positive 3. Yes, that's good. Negative 2 times positive 3 is negative 6, and I get 0 at the end. That's good. Now I'm going to synthetic divide out a 1. And I'm going to show you a trick. What I'm going to do is just kind of focus on the remaining constants here. 1, negative 4, 8, negative 8, 3, and try it again. So I drop down the 1, I multiply, I get 1. I add, I get negative 3. If I multiply, I get negative 3. If I add, I get 5. Multiply, I get 5. When I add, I get negative 3. When I multiply, I get negative 3. There's a 0. I'm going to synthetic divide out a 1 again. I'm going to be lazy and not rewrite everything. I'm going to copy down the 1. Multiply, I get 1. When I add, I get negative 2. If I multiply, I get negative 2. When I add, I get 3. If I multiply, I get positive 3. When I add, I get 0. Now, if it's going to be the case where there's 4 1s, I should be able to synthetic divide out a 1 again and get a 0. Let's see. If I drop down the 1 and multiply, I get 1. If I add, I get negative 1. If I multiply, I get negative 1. When I add, I get 2. That's not a 0. So it's not the case that I have 4 1s. I'm going to have just 2 1s, right? I have a negative 2, a 1, and a 1. And in order to find the remaining, what I'm going to need to do, let me erase this because that did not work. 1 was not a 0. I'm going to have to solve the equation x squared minus 2x plus 3. And I know I can't factor it. It's going to be imaginary solutions. Use quadratic formula. It's going to be the opposite of b, or minus negative 2, plus or minus square root b squared, or negative 2 squared, minus 4 times the a value 1 times the c value 3. All of that over 2 times the a value 1. So that's going to be positive 2, plus or minus the square root of negative 2 squared is 4. Negative 4 times 1 times 3 is negative 12. That's all over 2. So I'm looking at 2 plus or minus the square root of negative 8 over 2. The square root of negative 8 is going to be, I think, 2i square root of 2. Now each of these are divisible by 2. So I end up with 1 plus or minus, these 2's cancel, I root 2. So all in all, my solutions are, I'm sorry, I keep on getting asked by this program to rate it, and I don't want to rate it right now, and it distracts me. So my solutions are negative 2, 1, a 1, and then I got 1 plus I rad 2 and 1 minus I rad 2 for all 5 of my solutions. Good stuff. Let's do one more. Okay, so as I look at this next example, and everything's going to erase, which is fine because you have it written down or you can rewind. I look at this guy, and once again I'm being kind of nice to you because you have everything set equal to 0 in standard form, and this one looks like I could maybe group things up. Now if I group these guys up, I can pull out an x squared, and I'm left with x plus 1. However, if I, what I really should have done is put the parentheses around the negative, right, like I showed you guys. If I do that and I pull out a negative 1, I'll be left with x minus 15, and you'll see these binomials don't match. So unfortunately, factoring is out of the question, right? So what's not out of the question now is using my calculator. So let's go back to the calculator. Keep in mind, we're looking for 3 solutions. Let's see what we get. If we type this guy in here, so let's turn it on, let's go to y equals, let's do x to the third plus x to the second minus x plus 15. I'm going to hit graph, and that's what I get. Now, again, keep in mind, this is a third degree polynomial with a leading coefficient of 1. The end behavior is such that you know it goes up this way and down this way. And what it looks like we're only seeing right now, if we kind of had a snapshot, right, is this, and it might do something like, oops, it might do something like that. And all we're seeing is this picture. And again, focus on the 0 that's over here, which looks like it's at -3. So I'm going to trace, type -3. Yep, -3 is the solution, and it's a cut. There's no repeated solutions. So I'm ready to do the math now that I know x equals -3 is the only solution that I have. I'm going to synthetic divide that out. It's 1x cubed, 1x squared, -1x, and then a 15 over here. So I'm going to drop down the 1. If I multiply, I get -3. When I add, I get -2. If I multiply, I get 6. When I add, I get 5. When I multiply, I get -15. When I add, there's my 0. So the remaining two solutions are locked up in the quadratic x squared minus 2x plus 5. And I'm going to solve that using quadratic formula. So the opposite of b is going to be +2, not -2, plus or minus the square root. B squared is -2 squared minus 4 times the a value, 1, times the c value, 5, all over 2 times the a value, 1. So that's going to turn into 2 plus minus square root. -2 squared is +4. And -4 times 1 times 5 is going to be -20. That's going to be all over 2 times 1 or 2. That is 2 plus or minus the square root of -16 over 2. The square root of -16, I think you will agree, is plus or minus 4i, because I can square root 16 and I have to poke an i out. And each of those are divisible by 2. So I'm going to get 1 plus or minus 2i. So at the end of the day, all of the solutions are, -3 is the only real one, and then I get 1 plus 2i and 1 minus 2i, and I have all three solutions to my polynomial. Thanks for watching, guys. I hope a couple more examples help.